Hello, my name's Adam, and I'm a technical director at Sparkbox. And this short talk is hopefully going to demystify Docker for those of you who feel kind of intimidated by it or think it's just a bunch of magic. Docker is an incredibly useful tool. It just has kind of a pretty steep learning curve because it touches so many other parts of application delivery and just general software development things. So hopefully walk through the basics of it and kind of demystify some of the parts that can be intimidating. So you should see two windows on your screen. One of them is a terminal window, and the other one is a browser. Now, in the terminal window, I just have a simple index.php file, and I'm not kidding when I say simple. It's literally, it echoes hello world. That's all we're doing there. I didn't want to get sidetracked by a bunch of intricate application specific things and trying to strip away some of the magic around Docker. So our whole goal is to take this index.php file and load it in the browser over here at localhost 8080. And how we get from here to there, we'll hopefully uncover some things that you can do with your Docker setups to help you feel more confident and be able to approach some problems in a more efficient way. So the first thing you do, or that I do with a project like this that I want to Dockerize, is I make a Docker file. And a Docker file is just a way to describe a Docker image. So the first thing we're going to do is we're going to specify the image we want to start with. Docker is really cool because it lets you compose different images together inside your Docker file. So after the from keyword, you can specify any image on Docker Hub as your starting point and then build in the specifics of your application on top of it. And that's really powerful, that idea. In our case, though, we're not going to do that because that's, again, kind of magical. So I'm just going to start with an Alpine Linux image. Alpine Linux is often used as the basis for Docker files because it doesn't really offer anything other than a package manager and the Linux kernel itself. So the left of the colon is the image we want to use. To the right of the colon there, latest, is a tag. The colon is very powerful, and it is used in lots of different places around the Docker ecosystem. So you'll see at least two other instances of using the colon to great effect later on. But for now, just know that there's lots of different tags for images, and most of the time those tags are tied to versions of images. And in our case, I know that 3.11 is one of the more recent versions of Alpine Linux, so I'm gonna pin to that specific version instead of just using whatever happens in latest. So we have our Docker file now. And now we need to build it. And so I find using the help keyword or option with command line tools to be super helpful, just to get a bird's eye view of what's going on and to get some general idea of like the usage of that tool. So in our case, we're going to say Docker build, and then you just give it a path and some options, and it will build that image for you. So this is a really common thing to do. Just use the dot to specify the current path. And then we're going to give it a tag because you see we have this -t right here. And so we're just going to call this Docker demo. Really creative name, I know. So that happened pretty fast. And that's because we're not doing much, right? It's just Alpine. Alpine is really small, weighs in at around 5 megs. That's another reason why it's a good choice to start a Docker file with. And so it built it. Now, this is kind of the build and run feedback loop that Docker and a lot of software actually gets you into. And so in this case, Docker run has many more options than Docker build, which makes sense. It's kind of the way that you kick off your application. But for now, let's just look at that Docker run, take some options, and then an image name. So we have an image name, right? So let's run our new image. Let's see what happens here. And nothing happens, because there's nothing else going on in our Docker file. And that's fine. Now, I mentioned that Docker run is kind of the second part of the build and run feedback loop with Docker. I find that often it's easy to get bogged down into that feedback loop, and you're not really experiencing any like live feedback as you're working with this technology. So one thing that I like to do is I like to leverage these two options, -t and -I. I keep standard in open, even if not attached, like it says, and -t is short for TTY. Now what those do, those are really powerful because you can do this. So I've added those two options, and now you'll notice my prompt has changed, right? And so if I type who am I, which is a built-in Linux utility, it says root. If I exit, and so now I'm back on my laptop here, It says I'm A Simpson. So if we run this, you can see that we're kind of like, for lack of a better term, we're SSH'd into our Docker image, right? Which is into the running container itself. So this is really powerful. We almost have kind of a REPL-like experience here where we can play around within this container, and because it's ephemeral, we can't really break anything. So we can touch fake file.txt, right? So now you can see we have a fake file.txt. If we exit and then we go back in, it's gone, right? Because everything in Docker is ephemeral unless you explicitly persist it. So one of the things I like to do once I'm in an image like this in the running container is to do the work of getting my application set up this way, because this is much more immediate and feedback is much quicker than doing a whole build and run loop, especially as you add more and more pieces to your Docker file. So APK, I know, is the package manager within Alpine Linux. It's equivalent to Homebrew if you're a Mac user, or if you're on like Ubuntu Linux, something like that. It's equivalent to apt. So the first thing that any package manager needs is it needs to know about all the packages in the world. And so APK update does that. And now we have, just over 11,000 packages that we can install. So now we need to think about what does our application need? How is it going to serve up that index.php file to localhost 8080? Well, a really common way to do that is with Apache and PHP. So we know we need PHP, right? So we can do that. And then the next thing we need Apache. And so Apache is it's a great web server. We could have used Nginx. We could have used PHP's built-in server, but I think it's more interesting to use Apache and PHP because it's so popular, right? So we have these two packages. And now the other thing we need for our application is we need a way for Apache to understand PHP files, because by default Apache doesn't understand anything other than HTML, which is fine. That's what it's doing. That's its job. But I know that there's another package called PHP Apache 2. Okay, so we can run this. It installs our packages, and now we can do this, and we can see that we have PHP 7.3.16 installed. Now, if I were to exit this and then run this again and do this, PHP is not found, right? So we do need to run these commands here to get things working. All right, so PHP is now installed, and we have the HTTPD. I can just run it, and the HTTPD daemon is running. So this is great. We can actually verify that Apache is running in the background if we just curl localhost now, because we ran it. So curl is just a command line HTTP request tool. And so we can see if we request localhost, which is where HTTPD is running, we get it works. So that's great. So right now, I've done some work, and I am feeling good that I know the pieces I need for my application work. So it's time to persist those into a Docker file. Because remember, when you get out of this REPL here, it's not going to work because it doesn't persist anything by default. So what we need to do is we need this line. We definitely wanted, right? And then we wanted this update line. Okay, so let's exit and let's open up our Docker file. And so we can do this, and this is literally after the run command. It's just like we're invoking these directly inside our container. So the run command is just the Docker file keyword for running commands in your container, or in your image when you're building your image. Double ampersand is a way on the command line to say if the thing to the left succeeds, then also run the thing on the right. And I'll stop here for a moment. Docker assumes a lot of fluency and comfort on the command line. If you're struggling with Docker, it might not be that you don't understand how Docker works. It might just be that you're not comfortable enough on the command line to really navigate around and feel comfortable that way. So if that's the case, there's plenty of great courses that are worth your time of leveling up on the command line, and then maybe Docker might make a little more sense at that point. But the other things we needed here is Apache 2 and PHP 7 Apache 2, right? So now we have those lines, and we can do a Docker build again because we did Docker run. And you have to build every time you make a change to the Docker file. Cool. Okay, so our build succeeded, and now if we do Docker run, look at that. PHP is installed already. You didn't need to do anything. So this is great. Now, you might be thinking, well, that doesn't solve the problem. This doesn't work now? Localhost 8080 is still not working. Right. So let's address that problem first. So remember, always check the help text for things. Docker run has a publish, right? And so what we do here is we can say -p 8080, which is, this is our, what we want, the destination for the port, and then our friend the colon, and then 80. Because we know that Apache is running on port 80 because we curled localhost earlier and it worked, right? So if we do this, now when we run HTTPD and we reload this, we see that the it works message shows up locally. This is cool, right? Our ports are forwarded now. We have our Apache running in our Docker container, and it's forwarding out to our host machine. This is great stuff. Now, I want to pause here again and say, you need to understand the things you're packaging up in Docker to be able to really leverage Docker. And so in Apache's case, in the etc Apache 2 directory is where all the configuration happens. And so the HTTPD conf, this is the standard configuration file. You can go look it up on Apache's great docs site. But this is, you need to be able to understand how this is configured for your application to work well. And so this is just loading a couple modules. You can set the server admin, you can change all that stuff. Now, this is important to note, though, is like the document root, which is where the file that we're seeing here lives by default, is var.dub localhost htdocs. And that is visible inside the Docker container here. So var.dub localhost htdocs. Hey, look, it's an index file. And if we look at it, it's the it works. That's great. So the other thing that we need to understand is, I keep doing cat, I want to do this. Here at the bottom, include optional, anything that's found at this path, basically append it to this file and treat it that way. So if we were to look in the confd, there's this PHP7 file, which is what we installed, right? So this is how the PHP is loaded, and then this adds support for the PHP file type. When it finds it, it knows what to do with it, right? So again, you need to understand how this stuff works for your application to work well. So what do we have right now? Well, we have a Docker file that pulls in the dependencies we need. But then on the command line, we're having to forward some ports, and we're having to start HTTP, because as soon as we exited this doesn't work anymore. And we still have to run HTTPD manually. So let's address those things real quick. The first one is, let's just add HTTPD there. And now if we Docker build this, right? So Docker run -it. Actually, we don't need -it. 80 Docker demo. Cool. Okay, so we ran it, and now if we reload, nothing happens. And that's because the HTTPD is a daemon process, and so this is tricky here. When we said in the command to run it, it's running it, but then the way this works is it forks to the background, and so there's no process that Docker is noticing that's preventing it from shutting down. So Docker is just saying, well, the application must be done, and shuts down. So we need a way to tell the Docker file, or to tell HTTPD to not shut down. And we're going to do that with the -d foreground flag. So if we do Docker build again, and we run this, hey, look at that, it's open. It's still there, and now this works, right? Now the last step is we want to have this be our PHP file, right? So again, let's look at Docker run at the help, and there's this option here, this volume binding. So if we do this, and we have to give the full absolute path here, we can do index PHP, cool, var www localhost htdocs index.php. Right, so if we run that and we reload here, that works, but it doesn't say our file. But if we do PHP, yay, look, it says hello world. Now, the goal though was to have it, without having to specify the file name. So that can also be fixed here in the Docker file. So remember when we saw that index.html file? We don't really need it, do we? Not for our application, we don't. So we can remove it. So we can do it this way, and just, again, this is a run command, so just like we were actually at the prompt in our container, we can say rm that thing, and now we can rerun our build, and now we can run this command, and when we reload this, we get hello world, because there's no index.html file taking precedence over our PHP file. And so there you have it. We've taken our index.php file and we've packaged it up, this application, and we've injected it into a running Docker container, and we can see our application running in the browser. Hopefully this clears up some of the magic around Docker, and that you feel a little more in the know when you see Docker files and what's going on there. So thanks for watching, and if you have any questions or feedback, please hit me up on Twitter, _Simpson. Drop me an email at adam@heysparkbox.com. Thanks for watching.